start with complex number of part 2. Complex number part 2. In part 1, we have defined what is a complex number. And I defined a complex number as z is equal to x plus I1. X, y are real numbers and I is an imaginary number or an imaginative quantity. And I defined I as root over minus 1. I define what is real number also. X and y, when we are saying it is a real number, so that means x and y are either rational numbers or irrational numbers. I define what is irrational numbers and gave you example of pi. And similarly, I define what is rational numbers. That is even numbers, odd numbers, prime numbers, composite numbers, integers, whole numbers, natural numbers, and so on are examples of rational number. Today, we would start with conjugate of a complex number. In fact, in the last class, we also discussed that a complex number can be graphically expressed also. We can express a complex number in a plane, and we name that plane as Argand plane. Today, our area of discussion is firstly conjugate complex number, then modulus, and the third will be amplitude of a complex number, and lastly it will be modulus, amplitude, form of a complex number. A very important part of complex number. So I start off with conjugate of a complex number. Let us suppose z is equal to x plus I1. Then its conjugate is defined as z bar, which is equal to x minus I1. X plus IY is a complex number. Then its conjugate is x minus IY. Simply changing the sign of the imaginative quantity or the imaginary part of the complex number. So if z is equal to 3 plus 2i, then z bar is equal to 3 times 2i. Simply changing sign of the imaginary part. Similarly, if we are finding conjugate of the complex number, z is a complex number, z bar is its conjugate, so therefore z double bar is conjugate of the conjugate of the complex number. It is simply equal to z, that is 3 plus 2i. So therefore, for any complex number z defined as x plus I1, its conjugate is defined as x minus I1. So this part is clear. Now the part is modulus and amplitude of a complex number. Proceeding to that, Now, in the last class, I made a very important inference that a complex number has a graphical representation. I can express a complex number graphically, and that plane is not called a Cartesian plane as in analytical geometry. It is called an Argand plane. So this is the y-axis, this is the x-axis, and I define a complex number pz x plus iy equivalently written as xy. Z is equal to x plus iy is a complex number, and I express, or it can be expressed as x comma y in a coordinate form. And we express this particular complex number referring this part, this particular part is x, this part is y, and I define a complex number x comma y. This is my graphical representation. This is my representation of complex number in Argand plane. After expressing this in Argand plane or x or y axis, z is equal to x plus iy, I find that this complex number, if I measure its distance using coordinate geometry, this is equal to root over very important point I am about to discuss. Now the point is, in our complex number system, distance has no meaning. Distance is not defined as far as complex number is concerned. To in fact define other method of finding distance, here b, distance from origin, is root over x squared plus y squared. That is what is defined as modulus of z. Therefore, modulus of z defined as is the root over x squared plus y squared. Distance is not defined in case of complex number. But when we say modulus of a complex number defined as mod z, or you write between two parallel lines, means root over x squared plus y squared. If suppose I have z is equal to 3 plus 4i, you neglect this I, only the x only the x and y portion is to be considered. X here is 3, y here is 4, so mod z is root over 3 squared plus 4 squared is 5. 5 is the modulus of the complex number z, 3 plus 4. Simply the real portion, simply the real part, 3 and 4 you square, that is what is defined as modulus of a complex number. This particular complex number has image here, and it can be expressed as minus x plus iy. If I consider this with respect to here, it would be minus x minus iy is a complex number in the third quadrant. This is the second quadrant. This is the third quadrant. and in my fourth quadrant, I would have complex number as x minus I y. So therefore, a complex number can be graphically expressed and it is said to be an Argand plane, not Cartesian coordinate system. We call it an Argand plane. And when I express a complex number, distance not defined in place of complex number system, and that is here is defined as modulus of a complex number, which is small z. I now move on to define more amplitude of a complex number. Amplitude of a complex number. Let us start with this is my complex number. P Z x plus I y. I have defined modulus. I join this particular line. I draw a perpendicular on the x-axis, x, y. This is, I am measuring this angle. Here, this theta is defined as amplitude of complex number Z. Now, your question could be, if the complex number is drawn to the second quadrant, then what is the amplitude of the complex number? We may call it argument or amplitude. Then the angle measured is moving from the anti-clockwise direction, from the positive direction of x-axis, and that may be expressed as positive sense or negative sense. If your complex number is in first quadrant, then it is x plus iy. The complex number is in the first quadrant. Then amplitude Z is equal to theta is tan inverse y by x. Tan inverse y by x. Do not get confused by this inverse. We have not discussed inverse as far as class 11 syllabus is concerned. It simply means, to make things clear, that if suppose I write tan inverse root 3, it is equal to 60 degree. It is the principal value tan inverse root 3. The principal value is 60. It has infinite set of values which we will discuss when you study trigonometry of class 11. Similarly, when I say tan inverse 1 by root 3, then 30 degree is the principal value. 30 degree is the principal value, and it has an infinite set of values. But for the time being, you have to consider only the principal value, 60 degree and 30 degree. Similarly, tan inverse 1 and so on. So if the complex number is in the first quadrant, we would take the positive part, x and y, and find its inverse. That is defined as amplitude of the complex number. Now, if the complex number is in the second quadrant, Z is equal to minus x plus I1. The complex number is in the second quadrant. And how do I determine the amplitude of this z? Then amplitude z is equal to pi minus tan inverse y by x. Do not consider, let me put a modular sign out here. Do not consider sine of x. Do not consider sine of y. Only the positive value of x and y. Pi minus this gives you the amplitude of the complex number. So therefore this angle is pi minus tan inverse y by x. And if the complex number is in the third quadrant, that is z is minus x minus I1, then amplitude z is equal to pi plus tan inverse mod of I by x. Very simple technique. And you may express this angle in negative sense also. This is the positive sense. When you move on, you can express it in negative sense. 120 degrees or minus 240 degrees. 150 degrees, you may express it as minus 210 degrees. That means you can express in positive sense as well as in negative sense. So this is the third quadrant. And when we move on to the fourth quadrant, then amplitude z, complex number is in the fourth quadrant, then amplitude z is 2 pi minus tan inverse of y by x, or minus tan inverse y by x. Simple method is this. You need not get confused. I have told you the simplest of the technique of finding modulus and amplitude of the complex number. Then any whatsoever complex number is given, first and foremostly, we would locate which quadrant the complex number is lying. If it is in the first quadrant, it is tan inverse y by x. I put a model sign here also. Though it is always positive because x and y is in the first quadrant. So therefore it is positive. So therefore theta is equal to tan inverse y by x. I define, if there is any confusion, what does tan inverse means. It simply means that we would consider the principal value. Tan inverse root 3 is equal to 60 degrees is the principal value. And tan inverse 1 by root 3 is the 30 degree is the principal value. Then it is an infinite set of value. So, now when we come to the second quadrant, the complex number will be x negative, y positive, because in the second quadrant x is negative, y is positive. We know from class 10 knowledge, and similarly this is both positive. So the complex number is there in the second quadrant, and when it is in the second quadrant, the amplitude is defined as pi minus tan inverse absolute value. Do not consider sine of x and y. Do not consider x is minus x. Simply put y by x, that is defined as that inverse. If in the negative sense you find, simply this minus 2 pi is added with this to give you the negative sense of this angle. Then the third is, if the complex number both of them are negative, you can easily locate that x and y are both negative. So the complex number is in my third quadrant. It is in the third quadrant. So And moving on to the fourth, that is x negative, y positive. In the fourth quadrant, already know if the complex number is in the fourth quadrant, that is z is equal to minus as well. This is x minus y. Therefore, my plus x minus iy. If that be the case, if the complex number is in the fourth quadrant, x is positive, y is negative, we would consider the absolute value at 2 pi minus tan inverse pi by x. Or you may write this is the amplitude of the complex number. The last article is modulus amplitude form of a complex number. We also call it the polar form of a complex number. Z is equal to cos theta plus I sin. Mod Z is root over r cos theta plus r sin theta is equal to r. And amplitude Z tan inverse r sin theta by r cos theta is equal to very important form of complex number. Many deductions, many proofs are done using the modulus amplitude form of a complex number, or you may call polar form of complex number. This is how you define Z is equal to R cos theta plus I sin theta. And I am determining modulus of Z. When I am determining modulus of Z, simply squaring the real portion is what? R cos theta. What is the imaginary portion? R sin theta. I am squaring both because we know how to find modulus of a complex number. And I find that the value of modulus is equal to R. And when I determine amplitude Z is tan inverse pi by x. And here the value is coming out to be theta. So therefore, any complex number can be expressed in terms of modulus amplitude form of a complex